So, hello everyone, welcome back to ABL Education. So, previously we have done many sensors, many coding sections, and in today's session we will start a new topic. In today's session, what we are going to do, we are going to make a 7 segment display, and which is going to count any incident. Let's suppose you have a certain sensor which detects any incident or digital sensor, so you can count and display the data or how many times the sensor has been high or low. So it is like, let's suppose if you are using any obstacle sensor, then you can guess how many times the obstacle has been detected. Or let's suppose if you are using a motion sensor, you can also count how many times the motion has been detected. You can also make a useful project out of it. Let's suppose if you want to count entry and exit at any place or at any certain area. So simply you can put the sensor over here, and at entry gate and exit gate, it will keep counting, and it will display that how many number of incident has been happened over here. Okay, or how many times it senses that any person is passing over here. So simply what we are going to do, we are going to use a motion sensor, and we will use a 7 segment sensor display, and the 7 segment display we will use to print the output data or number, that how many person is counting. So let's start, and first we are going to use the Arduino as usual, and we will use a breadboard. So these are two things we have used, and the other thing we can use any sensor we could use, if you want to use any transistor, or if you want to use photoresistor or PIR sensor. So there are multiple sensor, you can use them also. But the thing I want to say that I am going to use a digital sensor, which is here PIR sensor. So PIR sensor will be used to detect the number of incident or motion happening. So if I use the photoresistor, it is an analog sensor. So I will need to map the data and then decide that whether the or convert it to the digital. So okay, so let's see what we can do. So we have inserted like our PIR sensor, or which will detect the motion, and now we need to insert a display, that is 7 segment display. So we are going to search here 7. So here we have 7 segment display. So now before we start, you already have seen like how we can use this sensor. So this sensor have like signal, power and ground pins. So we will connect the signal, power and ground with the respective sensor or the respective pins. So let's suppose I want to connect the signal pin with the let's suppose I want to connect the signal pin with pin number 2. So now I have connected this, and we have like power pin over here. So I will connect the power pin with positive, connect the ground with the ground, also connect the ground with the ground of the Arduino, connect +5 with the +5. Okay, so it's like we have connected our sensor. Now we can read the sensor and we can check the data, but our output device is a 7 segment display and we have not connected it. So whenever you will use a 7 segment display, there are two types of 7 segment display. One is common cathode type and one is common anode type. So we don't know which sensor is it. So what we are going to do, we are going to just use the common, connect it with the ground, and use the DP pin. That one is DP dot. So DP pin, connect it with the positive. So just connect it and then start a simulation or give the power supply. If your DP pin turns on, it means you have connected, your connection is right. If it does not turn on, it means your connection is not right. So we can see that our DP is not turned on, so our connection might be wrong. So we are going to switch it, and okay, now let's simulate again. So now connection is right, but we have not used the resistor. So what we are going to do, we are going to use a resistor in place of, okay. So let's start the simulation again. So you can see that our DP pin is now on. So we have checked and we know that it is a common anode type. So it means the common point will be connected with our positive pin. Okay. So as far our connection has been like checked, and we have also checked the type of our you can see also that here it is given like common anode. You want, you can change it to common cathode also. So we will use like common cathode, so I have changed it. So I will again connect it with the ground. Okay, so now I have connected the common cathode or common ground with the ground, and the other pins are like I have not connected it, but now let's connect the other pins. So I am going to switch to any color, and then we will connect it. So make the connection, connect all of them with certain pin, and then we will see the program. So I will explain like which pin I have connected. So just I will be back in some time, and I will show how I have connected. And the connection does not matter, whichever pin you have connected, you will define in the coding section, and you will find that how we have connected. So let's check the connection and then define it in the code. So it does not matter how you connect. So just I'm skipping because it is time taking. So just for a minute. So we have like connected all the pins, and now I'm going to show you that how we have connected. So the sensor part I have already shown. So this is like our 7 segment display. So I'm going to zoom in. So you will see that there is a common. So this is internally connected. So that's why I have connected only one common with the ground with the help of a resistor. So but I have not connected the other common with the ground because it is internally connected. And you will see that there are like number A, B, D, P, C, D, and E, F, and G. So if you want to know that which pins is connected with the which segment, so this DP will be connected with this dot, and this A is connected with this upper one, B, this one B, A, B, this one is C, D, E. So now you have here E, and this one is F, so here is F, and this one will be your Z. So like A, B, C, D, E, F, and middle one is G. So always remember it, and I can show you also here that which pin is connected. So you can see that there is A, B, C, D, E, F, and G, and this one is DP or dot point. So here also shown like A, B, C, D, E, F, G. So similarly, whichever pin we have connected, like if I have connected this E with the pin number 4, then I will define the coding with the pin number 1. I have connected this D with the pin number 3, so I will define accordingly. So let's move to the code section, and so what I'm going to do, I'm just going to define the number of the all pins, and then I will int and then equal to and then comma. So here int A. So let's check. We have connected A with the pin number 8. So A will be 8, and we have connected B with the pin number 9. 9 will be our B. So you can see here. So this pin is B. Similarly, you have to define all the pins. So now define our like int, that is our sensor, and sensor is connected with the pin number 2. So in pin mode we are going to define A to be output, and similarly we are going to define like B, C, and D to be output. So we are going to define all the 8 pins. So it will be like A, B, C, D, E, F, G, and our DP, that is dot point. So we have defined our all the pins. Now we are going to define our sensor. Pin mode, that is our sensor, comma, that will be our input pin. So now we have defined all the pins, and in today's session I will like show you something else, that will be like to create a setup. So what I am going to do, I am going to create a different kind of setup, and let's suppose initially you have seen like wide setup. So now I am going to create a different setup, that will be wide. Let's suppose 1, then 1. So whenever I call this setup, it will execute whatever written in this setup. So for this I am going to digital write. So let's suppose if I have to make here 1. So you know this one is A, this one is B, this one is C. So I am going to turn on the one, I mean B and C. So our B and C will be high and rest other will be low. So what I am going to do, I am going to digital light B comma high or 1. So we know that 1 is also high. So this is how we write. Similarly, I am going to write for the other also. So for making it fast, I am going to write like so like A. So we know that A is going to be low. So here our A is going to be low. So A will be like 0. Okay. So I am going to write a dummy one, that will be our digital write blank comma blank. So this is like I am going to use again and again. So it's like I'm going to use all the like C, then D, then E, then similarly F, G and DP. F, G, H, sorry, DP. So you can see that I have defined all the pins and I have mentioned that our B and C will be on or high and rest other will be low. So this one is going to be 1 and the rest will be low. So whenever I call like this function 1, it will execute like this, and so whenever I call in the loop, it will execute this one only. Okay. So let's check just after calling this what happens. So let's suppose if I run it now, so you can see no lights turns on, but if I call this function like 1 in the loop, let's see what happens. So you can see that it is showing like 1. So similarly what we will need, we will have to make all the function similar to this and then we will see what happens. So just I am making it quickly and then we will see the main part of coding. So I have shown you like making just one function, that how you could make and let's suppose if you want to make a 0. So if you want to make 0, it's like you will have to turn off the G, that is G, so middle one, and all other will be high. So G and DP will be turned off low and everyone will be 1 or high. So let's see in the coding. So now we have created like all the setup for all the numbers. So like 1 2 3 4 0. So I have called all the numbers, or we can say all the setups. So now we are going to move to the programming section. So let's suppose if I want to count the incident, then I am going to make a variable. One is the state. So integer state. So let's suppose initially our sensor state is like low, or we can say 0. So our initial state is 0. Let's suppose I want to count the incident or anything else, then int incident, or we can say count. So count is 0. So initially there is no incident, or we can say no count, number count. Now we will move to the loop section, and there what we will do, we will read. Let's suppose if I'm going to digital read our sensor sense. If I have just read the sensor value, and if it is high, then what we are going to do, we are going to enter in a if statement, and then we will execute. So here, like if our state is high, or we can say if our initial like sensor is reading the value, what we are going to do, we are going to digital write dp comma and also I'm going to change the state, because now sensor is high, so I'm going to change the state equal to 1. Okay. So if state I have changed like state to 1, so now our state is 1, state has been changed, and going to increase the count equal to count plus 1. So and also I have increased the count. So now what we have done, we have changed the state also. So here we can do one more thing, we can insert, or we can here like check that or execute only if the previous state is low. So what I can do, I can like use the and check the state equal to low or 0. So if the previously state is 0 and sensor is if high, then only it will execute the data. Okay. So now count is like we have executed, and now let's see if else what we can do, else we are going to change the state to low again. So state will be 0. So you can see that what we have done. So this is very simple. If state has been changed and if it is high, so it will not go in the else statement until the it is high and the state is like 0. So I think we have made a little mistake. So rather than using else, I am going to use if again. So in if, what I will do, I will check both the statement. If digital read, if value of the sensor is low and state is 1, then it will execute the this one. So like I have used simply one thing. Even if I have changed the state to 1, it will not go into the else statement until it have like sensor value goes to 0 again or low again. So when the sensor value will go low, then only the if statement of the second if statement will be executed. So then it will turn the state to 0. So we can say that the incident, this is incident will be counted again if the state of the sensor is changed. So that's how we can count the how many number of the time the state of the sensor has been changed. So this is just like not the complete coding because we have not completed yet the printing of the code over here. So what we will do, we will now in this loop we will execute another thing that will be our. So whenever we turn it off, make sure to turn off the DP also. Otherwise, we would not be able to recognize that whether the sensor is detecting anything or not. So make sure to turn it low. So now half of the coding has been completed, and in this if statement, what I am going to do, I am going to use like another if, and that will check the value of count. If count equal to 0, then it will print 0. Then it will call the 0. So that's it, very small like if statement. So I'm going to check all the if similarly. I can use like else if. If count equals to 1, then I'm going to print 1. So similarly we will do for the other also. So we have like written everything like here. So these are the setups I have created. This is like wide setup. The pin mode have been defined in the wide setup. then we add 1 2 3 4. So different number, for different number there is a different setup is included. And now if the state is high and previous state was like low and now it is reading high, reading is high, then now what happening, it is like changing the state to high, and it is like digital writing the high value of the that state is currently high, and also it is checking that whether the value or count is 0 1 or 2. So if it is 0 then it is calling 0 1 2 3 and so on. So also we can see that it keeps increasing the count value of count. So similarly you can see there is only 9 number could be written over here. So if the count is like 10, I have like redefined the count to 0. So if you have more number of the display, you can increase the value so far. And in other if statement, what we have done, we have like checked the state is 1 and digital read sensor value is 0. Then we have turned the state to 0 and the digital light DP to low. So now let's check the circuit and see what's happened. So it is showing like state 1 was not declared in this scope. So let's see where is state 1. So here if state equal to 1, okay. So let's so you can see that currently sensor is not detecting anything, but let's see if there is motion happens, what is happening, what is going on. It changes the value and printed the count value, okay. So now it is showing that value is like 1, okay. And if the motion happens again, let's see if the again if motion happens, it has written like 2. So motion should be happen after the these two LED turns off, then we can initiate the motion again. So it is like 3. So you can see that number keeps increasing, or we can say it is counting the number of incident going on. So if it turns off, then it will detect other motion, that is 4 now. So it is counting the number of state change. So currently it is high. So if I keep moving it, it is like 5. And if in between, if let's suppose I am giving the motion to it, it will not detect it, or it will not count it, because this is a continuous kind of data. So for continuity, it will check only the state change. So now if I move it 6, and then so I just want to show you that after 10 it returns to 0 or not. So 7, let's see what happens. It turns off, and 8. You will also so now it is 9, and after 9 it should be 0. like it is not counting the value to our 0 because we have placed it over here. So whenever before checking it is like changing the value, so I should place it like at another place. So I am going to place it after 9. So first what we will do, it will check and then it will add the value or add the number. So you can see it has also printed 0 now. Initially it was not printing because before printing it added the number. So that's for today. Thank you everyone.